Two heat recovery steam generators produce steam that is generated by using the exhaust gas heat coming from two Siemens Westinghouse gas turbines. The steam flows to the steam turbine through three steam lines, each with a different temperature and pressure. These steam supply lines are main or high-pressure steam, reheat or intermediate steam, and low-pressure steam. Main or high-pressure steam is generated at approximately 1,650 pounds per square inch, absolute, at 1,052 degrees Fahrenheit. Reheat or intermediate pressure steam is generated at approximately 354 pounds per square inch, absolute, at 1,052 degrees Fahrenheit. Low-pressure steam is generated at approximately 85 pounds per square inch, absolute, at 609 degrees Fahrenheit. The three steam lines, main steam, reheat steam, and low-pressure steam, pass through bypass valve intersections. At these intersections, the bypass valves may route the steam directly to the turbine or bypass the steam turbine and send the steam straight to the condenser. From the bypass valve intersections, the steam lines carry steam to motor-operated stop-check valves, also referred to as isolation valves. Leaving the motor-operated stop-check valves, the steam lines continue to the steam turbine enclosure. The main steam line has two sets of stop and control valves. There is one set for each main steam line that passes to the main steam section of the turbine. There are two sets of stop and control or intercept valves on each side of the steam turbine to control reheat steam flow. Low-pressure steam is supplied to the steam turbine through a single LP stop valve and LP control valve. The front pedestal is a name given to the housing that encloses the shaft coupling, supervisory instruments, turning gear, and the thrust and journal bearings. The front pedestal is located at the generator end of the steam turbine rotor. The turbine casing encloses the rotating and stationary blades. The exhaust hood directs the steam from the last low-pressure section of the turbine to the condenser. The front pedestal and turbine casing are located within the steam turbine enclosure. The 17 turbine stages are divided into three sections. There are 8 stages in the high-pressure section. A stage is comprised of one set of rotating blades and one set of stationary blades. Steam striking the blades of the moving part of the turbine, the rotor blades, causes rotation of the turbine shaft. Steam leaving the moving blades is redirected by the stationary or diaphragm blades in such a way as to approach the next set of rotor blades at the proper angle. There are 5 stages in the intermediate section of the steam turbine, and there are 4 stages in the low-pressure section of the steam turbine. There are 3 main bearings that are used on the steam turbine. The thrust bearing is used to maintain the rotor position axially so the rotating blades will not touch the stationary blades. 2 journal bearings carry the vertical weight of the rotor. The number 2 journal bearing is located in the front pedestal at the high-pressure end of the turbine. The number 1 journal bearing is located on the condenser end of the rotor shaft. The mechanical overspeed trip device is located on the very end of the rotor shaft on the condenser side. The steam turbine drives a generator to produce electric power. The steam turbine converts the thermal energy of the steam into mechanical energy. The mechanical or rotating force of the turbine provides the torque required to turn the generator shaft. The generator shaft rotates a large number of windings within a strong magnetic field, which produces the high-voltage current that is distributed to AEC customers through the high-voltage distribution yard.